Hello, everyone. Thanks for joining. We'll give it like a minute or so while others start to join in. All right. Hello, everyone, and welcome to today's webinar, Testing Biometrics on iOS. My name is Jason, and I am on the marketing side at HeadSpin here, and I'll be your moderator. Before I hand it over to Joe, I'd like to cover some few housekeeping items first. One is today's webinar will be available on demand after this live session a day from today. And we want to keep this sort of webinar interactive. So if you have any questions for Joe, please feel free to send it through the Ask the Question sort of icon on the right-hand side of this browser or window, and or tweet at us at headspin_io. I'd like to sort of kick things off and pass it to Joe and to introduce himself, but without further ado, here's Joe. Take it away.
Okay. Can everyone hear me just fine right now? I think so. I've got a new microphone here, so I'll start all over again. Hello, welcome to HeadSpin webinar. My name is Joe Chasinga. I'm a software engineer with HeadSpin, working with device instrumentation and the Biometrics SDKs for both iOS and Android platforms. So today we're going to be talking a little bit about iOS Biometrics SDK and how we can use it to automate our test on the iOS platform. And it's a newly released SDK alongside Android, which we have just released a version ago. So any feedback would be more than welcome. So let's start with what is really biometric. Biometric is the use of users' body measurements and calculations as metrics or keys in the process of authentication, identification, or control. The most common forms you'll know today include fingerprint scanning, face recognition, iris scanning, or even skeleton detection, as you might have seen the Xbox Kinect sensor. So here's a screenshot from a really popular Flex Minority Report from back from 2002. That was 15 years ago. As with many new technologies, they all start from sci-fi. You see here, Tom Cruise is actually engaging in one of the biometrics authentication form, the iris scanning, which is pretty interesting. Not sure if it's widely popular at this point. And let's jump into a more iOS specific biometrics timeline here. In 2013, Apple introduced its first biometric feature, the Touch ID in the iPhone 5S. And in the same year, it acquired a company called PrimeSense. It's a company behind the depth camera technology that powered the Kinect sensor. And this acquisition may have laid the groundwork to the recent Face ID technology, which Apple has released in 2017 in its iPhone X and later to replace the Touch ID. So at this point, it's worth noting for everyone that an Apple device can only use Touch ID or Face ID, depending on its model, but not both at the same time. Face ID was successor to the first and exists only in the iPhone X and later. Let's dive into the overall architecture of the iOS biometric authentication from a really, really high level. You'll see here that depending on the model of your device, it's going to have either the fingerprint scanner sensor and the depth camera, or the depth camera. And these biometric hardware sensors acquire the inputs from the user. And then there's the operating system, in this case, the iOS, of course, which manages how the applications interact with the user's biometric inputs via the iOS frameworks, or what are collectively known as the Xcode environment. And last but not least, here's a very, very important component in the iOS biometrics process. It's the microchip on the device called the Secure Enclave processor. So this processor is totally isolated from the iOS, has its own operating system, runs its own kernel. It stores the more sensitive keys and like raw data, and of course also the raw biometrics data. And the iOS operating system cannot access these data directly. So here comes the issue with automating biometric tests on the iOS platform. Since there's just no way to interact with or sidestep the biometric prompt in the test flow without any physical intervention, and there's also no way to programmatically intervene with the Secure Enclave processors. So I don't know, what should we do? One way is to hire people all over the world to run a sort of biometrics click form for all the iOS biometrics capable devices, where local gigs can just run their fingers or faces against all the devices in real time. That's interesting. That could have been a great business model that we could launch in the near future. But no, meanwhile, instead, we're just going to offer a more developer-first solution, which is it's a library or an SDK that would let developers to easily swap in a mock framework and facilitate the automation gracefully in the software layer without the need for any physical intervention. So here's what the SDK, where the SDK is gonna be. It's gonna exist in your normal Xcode environment, and it's gonna sidestep the biometrics prompt on the software layer. Okay, and here comes a video demo of myself just testing a sample app called the Authenticator app. So what this app does is it presents a login page with the login button that would trigger the biometric prompt, and it has a red background. And if the biometrics process is successful, it will change to a locked-in page with a green background. So let's see how it goes. So I just click the lock-in button here, and that's it. It's pretty quick. Let me repeat that again, just because it was so quick. There we go. Using my face, I could authenticate the app without problem. And then here's another version of the demo with the same app, the Authenticator app, but this time we are using the HeadSpin Biometrics SDK. This means that without my face, we're gonna try to use a remote HTTP request to do the same thing. So you see here, this is pretty much the old school curl command here. I just insert my token just like that. I send the post request, and just like that, I am in without my face in front of my device. I'll just repeat that again. So that's a post request to our HeadSpin API endpoint. And with the action succeed, I want it to succeed. And then voila, just like that, it works. So we're gonna get into the code just a little bit so that you can get started with using our SDK. But it's worth noting that before installing our SDK, our SDK actually just worked with iOS version 9 or later due to the SDK use of an API that's only available to the versions. And also, please don't forget to include an face ID usage description key in your app's info.plist, regardless if you're going to use our SDK or not. This is because if you forget this, your authentication process will likely fail. And the SDK is not trying to do something magical. So please be sure that your target device needs to be able to authenticate using its respective Touch ID or Face ID. In short, it means that the device needs to have at least one legit fingerprint or face for its biometrics to work, or for our SDK to work also, because it would be freaky if it did without. And last but not least, this goes without saying, please do not distribute your test bill in public. There's a great risk of people hijacking your app's biometric prompt using TCP connections. So only trust HeadSpin and no one else. Okay, let's get started here. To install the HeadSpin Biometrics framework, just firing up your Xcode here. I believe this is how most of your Xcode environment looks like. For your information, this is Xcode editor version 10.2. Under your project target, under General tab, right here, please find the embedded binary sections. And then you can either click the Add button and then locate your downloaded biometrics.framework file, or you can just drag the framework file right in here yourself to add to your project. And then clean your build folder. Just make sure your build passes. And in your code, try to import the biometrics module. If you're using Swift, just type import biometrics and wait a few seconds. If the Xcode does not complain, then you're good to go. And please do not forget also to install the SDK dependency. The SDK relies on this really popular networking library called CocoaMissingSocket. So for those of you who are into iOS development, you should have heard of this library. It's awesome. We recommend using CocoaPods to manage your project's dependencies, including the SDK's dependency. So to install CocoaMissingSocket, just include this right here, this pod file into your project. If you already have the existing pod file, just integrate this part and this part into your pod file, and you can type pod install or pod update to install the library. So once you're set up here, let's go into the nooks and cranny and do some walkthrough in the code. Okay, let's see how it goes. Okay. All right, so this is the sample app that I've shown you previously in the demo, the Authenticator app. Here is the view controller that controls the login view of the application. This is the conventional view without our Biometrics SDK. You'll have to import local authentication here, and then, to begin with, you'll have to instantiate an instance of LA context here. You're gonna be interacting most of the time mostly with this context instance. And then this part is where you actually just set up your application state. What's really worth noting here is you can actually inquire the type of biometrics that is available to the device. So right here, I just want to make sure that if it's a Face ID, then I'm gonna show the label. Or if it's something else, which is the Touch ID, I'm gonna hide this label. And right on to this point is the view.load method. This function gets called when this view actually has finished loading. Just make sure you call can evaluate policy here on the context instance. It's gonna return a Boolean value for you to learn that your device, whether your device is capable of evaluating the biometrics or not. So it's always a good idea to call this method early on before presenting any kind of interaction to the users. And then here is where the user interact with the Authenticator app. So this tap button method gets called when the when the login button is pressed. You'll notice here that we actually instantiate a new LA context instance and then reassign it to the same context variable. This is because you want to get a fresh context for every login instead of reusing the previous one, or else there's a chance that all subsequent logins are gonna be successful, which is usually not something you really want. And then you can just set the cancel title. It's a message on the button, the cancel button for the user. And right here you see that we call the can evaluate policy on the context again, but right now it's inside the conditional if block because you don't want to run any of these code in the block if your device cannot do biometrics. So, and here's the meat of the biometrics authentication. It's the evaluate policy method. And you call this method on the context instance, and then you pass the callback function here. This is really important. This callback function actually accepts two parameters, the success element and the error. And then just make sure you provide the case when it's successful. In this case, we're just gonna toggle the app state to locked in, which is gonna trigger the change in the UI to a green page or locked in page. And in case of the error state, in case of the error, you can always catch several types of errors here. For instance, user cancel is when the user actually cancels the prompt using the button. App cancel is when the code actually cancels the prompt, or system cancel when the OS actually cancels the prompt. And in the case of error, please always make sure to provide some meaningful fallback message to the users. This is really important for the interaction, for user experience. And then so user can gracefully fall back to typing the conventional username and password. Okay, let's check on the time a little bit. Okay, we're still good. All right. So let's now go through this code again, but I am gonna swap and use the biometrics module instead of using the conventional context. So right here, as you can see, please do not forget to import biometrics module here. And instead of creating the context, the LA context instance, you'll be creating type HSLA context. But before that, there's some detail here that you need to remember, is to always create a wrapper. Let's create a wrapper here, HSLA context wrapper. So it's another type, and then only acquire the instance of the HSLA context using the wrapper create context factory method. The reason for this is the wrapper itself helps to process the TCP connections in the app so that it can actually talk to the remote HTTP request calls. So if you use the HSLA context constructor directly at this point, so whenever you create a new fresh context, the TCP connection is gonna disconnect. So please make sure you remember this when you're using our SDK. And at this point, since you're just using the same context variable name, all the code stays pretty much the same here, because the SDK was designed to require really little changes on your side. Just this part, when you actually need to instantiate fresh context, use the wrapper create context factory method here, and then reassign it to your context, and you should be good to go. And one more thing is, oh, I'm sorry, this is a static number. So let's do that. And then, okay, here you go. You might want to call close method on the HSLA context instance as well, because this will help clean up any TCP connections before this field gets destroyed. Okay, there's some wrong stuff, that's fine. And one more thing here on the error side, there's a new extra error type called HSBiometric error, intentional error. This error gets raised when the user sent a remote HTTP request, the post request that I've shown, with the action value of error instead of succeed. This is the time or the case when you want to test the case that when the biometric prompts fail or it has error. So you can always catch this intentional error. And also, as always, please do make sure that it provides a graceful fallback to the end users. Okay, we're going to try to run this code and see if it's successful. Awesome, the build succeeded. So from here, okay, so let me grab my phone here. Whoops, Excuse me. So as you can see here, this is the same app right here, and when you press login button, I can still use my face to authenticate. So the only extra perk you'll get is that you can use HeadSpin API endpoints to actually do this instead of your face. Okay. Okay, seems like we have concluded early, and thank you everyone for joining this webinar. And just for you guys' information, there's going to be a separate webinar tomorrow, same time, on Biometrics SDK for Android. So please hurry and register. Thank you. I think this is the time for some Q&As. Let me see if there's any other questions. Okay, here are some questions from the audience. So how do I get the SDK? Good question. Please sign up with HeadSpin and you'll get the access to all our awesome products, including the SDK downloads for both iOS and Android. This another question. Does it work with Objective-C project? Yes, it does. The SDK is written in Swift. So that means that in your implementation file or the .m file, please import the header file instead. The name is biometrics.h, and it will work as is. And some other question. Can I test using the SDK on a local device? Yes, there's nothing stopping you to test on a local device, but you'll need to use TCP client and use a special protocol for that. So I highly recommend for you to test on our HeadSpin devices. Where can I read the documentation to learn more? The documentation is available to all HeadSpin customers. And if you're interested, please do get in touch with me or any other HeadSpin channels. We would be more than happy to walk you through. Any other questions? I think that's it.
All right, thank you, Joe, and thank you everybody for joining this webinar. Again, this recording will be available tomorrow in your inbox, so please take a look. Also, links, the handouts is available at the right side at the bottom icon. You can download the handout, or if you're interested, we can also send it to you by emailing us at marketing@headspin.io. So again, thank you everybody for taking this half hour to join us, and we'll see you again.
Thank you everyone.
Thanks everybody.
Thanks, Jason.